So hello everyone, and thanks for joining. We'll get started shortly, and we'll wait for some of the other maintainers to join in on the call. So Lee is here as well. Hi Lee.
Oh, hello. 10 is up late. I imagine 10's been up late for a week or more. I can only imagine. Yeah, so I'm going to talk about 10 on the recording, which is to say, like, she's very much appreciated, but also I can imagine is just going to crash after this week and turn off all email and everything else. Nice. Well, I'm going to go rally a couple of other maintainers, or they might be popping in now. And so let me grab a couple of folks. So welcome those that are coming. Bear with us one moment as we get a couple of other maintainers on, and we'll get started here in just a moment.
So as we go on with a walkthrough on what SMP is and how it all fits in the service mesh ecosystem, you can ask your questions in chat, and we'll try to answer them as we go on. All right. I think we have three of us here. Lee, let's get started, I guess.
It's time. Hey, all right. Hey, welcome everybody. I think we're recording, and we are. So hey, it's KubeCon China 2021. Nice to have you all on. We're going to talk about service mesh performance today. These are the project office hours for service mesh performance. So yes, you're in the right place. My name is Lee Calcote. I'm one of the maintainers of service mesh performance, but one of a few, and there are other maintainers that have joined as panelists today as well. And so I'm going to let them introduce themselves. So with Navendu and Mritika, and then there is, I might have passed around the wrong Zoom link, so I apologize, but Jing Hong as well. And so, yeah, please take a moment to introduce yourselves if you would.
Sure. I'll start off. So I'm Navendu. I work at Lairfy, and I'm one of the maintainers of the Service Mesh Performance project. And it is really nice to be here, and we look forward to talking to you. Over to you, Mitika.
Hi, I'm Ritika Ganguly. I'm an architect, principal engineer at Intel. I'm one of the maintainers of SMP. We have been working a lot on improving SMP and providing a lot of the features.
I am Xing Huang from Intel. And I am one of the contributors of the Service Mesh performance. And I focused on the Service Mesh acceleration in Intel. So welcome, everyone. Thank you.
Well, I guess Sheng, this is probably one of the only times that I'm going to be rubbing my eyes because it's really late here, and you get to sit there smugly and smile because it's daytime for you. So it's so good. Speaking of daytime and kind of why we're here and why I'm up late, sharing. I think I speak for the rest of the maintainers as we say, well, it's an area of interest, an area of passion for us. It's also, we're here for you. Like any one of us can probably talk your ear off for the next 40 minutes or however long we have, but please interrupt, ask your questions. We really are here to explain the project to you. Some of what it has accomplished to date, and some of what we're looking for it to accomplish. And part of what we're looking for it to accomplish really depends upon your engagement. So please bring your questions. With that, a little bit of backstory, a little bit of genesis about how this project came to be, and just a recognition that it's a specification, that it may not be the only specification that you're aware of in the service mesh ecosystem. 10 points for anyone who can tell me what another service mesh specification that comes to mind is. Does anyone else know about another service mesh abstraction? So we're talking about SMP, Service Mesh Performance. Something of a sibling project is Service Mesh Interface, or SMI. And I figured that as we go to introduce Service Mesh Performance and what it does today, what its purpose is, what the project is doing, that it also helps to kind of contrast it against Service Mesh Interface. So ever so briefly, if you're not familiar with Service Mesh Interface, it's also a specification. It's a set of currently 4 APIs that provide, well, a uniform interface to interact with any number of service meshes that have implemented behind those 4 APIs. Great, so it is generally concerned with describing service mesh functionality, like how to configure a traffic split, as an example. That's the domain of SMI. SMP, by the way, being a maintainer of both of these projects, like the 2 projects are like very much so kind of point back to one another. And maybe we'll share a slide at some point that kind of articulates this maybe better than my hand signals can. But service mesh performance is, well, it's set out to initially answer this age-old question of like, hey, there's a couple of questions wrapped into one. It's like, what's the overhead of running a service mesh? And part and parcel to that, so like the flip side of that coin is like, how do you measure the value at the same time of running the mesh? Because if you're asking the service mesh to do very little, you're not getting that much value. You probably also don't have much overhead. You can imagine there's some somewhat direct correlation between how much you ask a service mesh to do and how much overhead it might have. And so let me, I suppose, we'll stop sharing about SMI and we'll go share about service mesh performance and take a look at this slide deck. So I have a nasty habit of talking people to death about service meshes. And so I know that Xing and Ritika and Nivendu, I'm going to try to pause occasionally and they will absolutely interrupt me in a very polite way to tell me to shut up and let them explain some other parts of this. So on that, I'll say this, that so service mesh performance helps you standardize the way in which you characterize and articulate the performance of, like, specifically a service mesh environment, but more broadly, your cloud native infrastructure. So there's a maintainer from the CADA project, the auto scaling project, that's been quite interested in helping ensure that service mesh performance as a project, that its view over time expands past a service mesh performance and then just cloud native infrastructure much more broadly, infrastructure inclusive of like characterizing the application. So if you think about this challenge today, like there's a couple of questions that I suspect are pretty hard for people to answer. And so one of those is like, for a given layer of my cloud native infrastructure, how much is that particular layer costing me? Like, what's the CPU overhead or the memory footprint, or however you want to characterize that particular resource? How much is that thing consuming? Maybe that's you've got Fluentd running in your Kubernetes environment. It's generating logs, it's collecting logs, it's transposing logs, sending them out somewhere else. How much is that costing you? How much is that worth to you? Kind of a related question. Logs are pretty important. They really help you go sleuthing around and figuring out what's wrong with your microservices or any number of other things. Well, in a similar way, so that's one of the ways in which service mesh performance aims to help empower all of us with answers to those types of questions, like based on different configurations, of which there's like an exponential number, I think, of like different types of configurations. If you think about your environment versus your neighbor's environment, could be potentially much different, many different clusters of different sizes running different types of workloads under different stresses. And like it's sickening to think about. And yet people will ask the question, hey, what's the fastest mesh? I think I share this with the others on the call when I say that we desperately want to have an easy answer for that. And it's just not necessarily, I think we do a disservice if you answer it off the cuff. If you really want to know, because there's a lot of variables in there. I'm going to pause for a moment and let some of the other panelists maybe add some color as to the challenges around trying to answer these questions.
Sure, if I can add. So for example, if you have a system, a host system with different kind of CPUs from different vendors, the number of cores, the amount of memory, the last level cache, and how that is getting utilized when you deploy a service mesh with a certain number of clones, certain number of microservices, whether you add an ingress on the same host or you add an ingress on a separate host, the number of connections that are coming in, can you scale the number of connections? Can you, what would give you the best performance? How would you benchmark that? Would you be able to host 100 microservices, 1,000 microservices? If you do, how many clients can you connect? All of this requires data to be profiled from different environments within the service mesh deployment. So the right tool, the right way of measuring, the right views, so you can put them all together and then see whether the deployment is giving you the right utilization. If it is not, where is the bottleneck? All of that is important to be brought together, and hence SMP is attempting to get to that, to give you the best in a short time.
Well, you can never find the Zoom panel wherever you hit it to get it out of the way. You can never find it. Yeah, I was just, there's some great questions coming in, by the way. So I was going to tack on to something that Ritika was just going over, and that is that, performance is, well, it's a continual question. Like the answer changes on you. Your environment isn't necessarily static. As a matter of fact, the fact that things are ephemeral and that things change pretty often is like one of the, there's many different ways to characterize the difference between the way in which software used to be run and the way in which software used to be written and how it's done today. And so not only is a continual assessment necessary based on changes in different versions of the mesh, different configurations of the mesh, different changes in your environment, different versions of your app, and so on, but also then, like many things, the further left that you might be able to shift some of these considerations, potentially the better. And so the community had recently delivered a GitHub action to help to the extent that you're using GitHub as a specific CI system, as a specific example, to help ease in pipelining performance characterization and to generate load and to do a test against your infrastructure, your pipeline. And so that's been kind of part of the project. There, like one of the first things I think that a lot of people will come and ask, and Xin, as you've engaged, tell me if this is true for you, but when you first came to the project and were intrigued and started to click around and understand it, you might have been expecting to see like performance reports, like previously run benchmarks and metrics about the performance. Notably, like, is that true for you? Like, did you kind of expect to see that on the site? Like different performance statistics and different tests that have been run. There have been a number of those that have been published, and the reason that I call on Jing is because the community has done those in the past and published some of those reports. As a matter of fact, Ritika just got done writing an IEEE article on this particular subject. She talks about the methodology by which these things are done. But as you publish any performance benchmark and you do it statically, like there's that ugly word again, static, and not continual and not like repetitive, like not refreshing all the time. And so part of Xing coming to the project that we're just on the precipice of is really setting up a large set of different benchmark configurations using, and so I'll try to maybe go to a different slide just to give this some color to feel like we're advancing. But like there are about 5 different sample applications that, in terms of like tooling that implements service mesh performance, Meshery as a sibling project to service mesh performance, Meshery implements SMP, implements this spec, so it lets you articulate the configuration of your environment, your Kubernetes environment, to Mritika's point, like the amount of resources that you have there. It lets you describe your application a little bit, but then also what service mesh you're using and what configuration that service mesh has. And to the extent that Meshery implements service mesh performance as a specification, that becomes a uniform way of capturing that and characterizing it, such that then as individual users, you can take and run those tests consistently and establish your own baselines. Ultimately, what Jing and some of the rest of us are going to go do is run these tests against sample workloads and leverage the CNCF's labs, some bare metal environments, to go to do a number of Kubernetes deployments, deploy a number of different service meshes and sample apps, run them under different configurations. The configurations and some of how long we would run these tests, like how long repetitively, I mean, is like of active discussion within the project itself. The reason that we haven't published a lot of reports already is because they do get stale and they do get static. and so we don't want to do a disservice to any of the participating service meshes.
True, like you mentioned in one of your files, apples to apples comparison, that's important. When you are doing a deployment, you want to know, so I was speaking about number of connections, number of microservices. You also want to know what's the size of your messages. Is your application taking in messages which are 100 byte sized or 400 byte sized, or you have large byte sized messages? And each of those makes a difference. And the other thing is how many sidecars do you have, and can you have multiple containers within a pod with one sidecar? All of those decisions you can make if you can deploy and measure and benchmark. That's why the benchmark is an important part of SMP.
We just had a project office hours for Meshery, and one of the questions that we had in that project office hours was like, hey, how many service meshes can you name off the top of your head? There's a lot of them out there. And the reason that I bring this up is to say, is when Ritika is talking about sidecars and proxies, that's the most common model that most service meshes implement, is like, the data plane is comprised of a litany of proxies that are generally sidecar to your, and there's a couple of other models. There's one that's just like a single proxy per node. These different models have different pros and cons, like any architectural choice does. There's a forthcoming service mesh, like yet another mesh to be announced. I expect that we'll see it probably announced early next year. This one will be based on largely around eBPF. It probably isn't, it's going to forego sidecars, and it'll use a different data plane implementation. And so there's a couple of things that are kind of interesting about that, which is to say, one, like service meshes, new ones are still coming out. So like there's lots of early adopters of a variety of service meshes, often having success running them. There's more that are coming, and there's different types of data plane tech involved as well. And so eBPF as a topic isn't one that we've gotten to spend as a project community. We haven't gotten to spend a ton of time discussing that particular tech, but I think it goes without saying that like that's certainly within scope. Like that it's a valid service mesh architecture and comes with trade-offs. One of the trade-offs you might consider that might have some better performance. But as we were saying when we were starting this discussion, that there's kind of two sides to this coin, or at least in my mind, which is like, hey, there's the speeds and feeds of like what's the performance, what's the overhead, and then there's the other side of like what of the coin, which is like what value are you? How do you put a price or on the value that you're deriving from what the mesh is doing? And that's something that has been being wrestled with a bit and is under active discussion. And so Ritika in specific was giving this some, well, I don't know how deep of thought, it would like maybe deeper thought than I'm necessarily willing to articulate at the moment, but Ritika, on this, like to kind of recap this a little bit for those that are here. I know that in the past I've talked to people about service meshes, and they ask that question, which one's the fastest? Excuse me, what's the overhead of a mesh? How do I know if I'm doing it right? Like, should I configure it with this many retries? Is that beneficial to me? Like the more retries, the more resiliency, right? It's like, yeah, well, up to the point that you invoke accidentally like a retry storm or something. And then it's like, well, no, actually it's not more resilient. It's actually, you're killing yourself. You're hammering on yourself, yourself being services. And walking people, having that discussion time and time again, and like walking people through a characterization of a given environment. Like it kind of starts with, well, there's a cluster of this size. It's running on this type of infrastructure. And then like about, 10 minutes later, you're kind of done verbally articulating your environment, application, service mesh, configuration, all that stuff, load, consistent load, et cetera. And by the time you're done, you might have shared with each other any number of charts. Because you're measuring any number of different signals, and I won't stand for it, or like I can't do it. I'm going to go insane. So, Ritika, thoughts on that aspect of this challenge?
Sure. And yes, we are. I'm presenting in IEEE Edge. That's also being hosted in China, and in a week. Around December 17th, and some of our experiments that we have done, which service mesh is fastest. It all depends on how good your layer 2, layer 3 network is working. So you must have benchmark data for your layer 2, layer 3, which is the CNI layer. And what do you choose for the CNI layer? That's an important aspect of it. What data plane is being used by the service mesh, like Lee mentioned, if you are bypassing some of the Linux network stack using eBPF at the CNI layer, there are a couple of CNIs which have integrated eBPF. Now that will speed up some of it. So if you are doing a lot of IP tables lookup, your performance is slower. If the rule lookups are simple, your performance by lookup is not a whole lot. So look at your CNI layer and then look at your service mesh layer that is making use of some of these technologies, but at the layer 7. So what is the layer 7 performance of each of the different service mesh, whether you're using HTTP, gRPC, any of the layer 7s. So each of these are integrated differently. There are also service meshes which are process-based or thread-based. That gives a different kind of performance. There are meshes which are without sidecars, of course. That's the holy grail everybody is looking at. But remember, the sidecar is providing a functionality which is extremely important for the application, which is around security and observability and many others. Now, if you're removing the sidecar, there is some other entity which is doing that for the application. So is that entity also taking up similar amount of performance? So is it just a different design? If everybody is using Linux scheduling, all of them have the same bottlenecks. So all of these areas are areas to look at and designs to follow.
There, so it's worth noting that a couple of you on the call work for a hardware manufacturer or generally a chip manufacturer, and so there's got to be you were mentioning like Linux scheduling, to the extent that that's a uniform layer, but and I got to imagine. I mean, I don't. So I'm teeing up a question around. Where hardware comes into the picture, and and I don't know if there's any insights that you might be able to share on that, or
Yeah, yes, of course. Hardware, specifically the CPU, and that's what we work for, and where I come from. The CPU, the NIC, whether it's a regular NIC, a smart NIC. Whether you have any offloads within the hardware, what kind of amount of memory allocation, memory access, what do you look at, what do you interface with? So regular memory access with PCI Gen 4, Gen 5, and then we have a new connect called CXL from the CPUs. And then are you on a NUMA node when you are deploying? The services communicating with each other on the same host are they on a NUMA node. There are service meshes which are looking at different other protocols to enable data copies. So if there are DMA engines which are doing better in a certain hardware, so those are angles to look at. Number of cores, of course, is a game which different CPUs play. I would say, certain CPU architectures would provide a large number of CPUs, and so then they can say that I have 100 CPUs or 100 CPU cores, and so I can host many more. But what's the instructions per retired performance for each of those, right? Because instructions per retired would give you the performance. So if the performance of the CPU vis-a-vis the number of cores is a trade-off, that's something one can look at. And hence choosing the right hardware, choosing the right combination of hardware, what's the power level of each of those, what frequency are they running, all of those are important and should be reflected in the service mesh performance. Because when you want to do an apples to apples, you want to do that. Overall, am I getting the same performance from more number of cores, or am I getting it because the core with less number of cores, but at a higher instructions retired cycle, right? So
another question along those same lines, as you talk about, servers with many core or chips with many cores. There's implicitly some amount of overhead in terms of context switching. And like, is this next statement? Let me put you on the spot and ask this, which is like, this is probably a terrible question, but I've got to do it, which is like, is the most efficient alignment for a given application, if it's a multi-threaded application, is it like the peak performance for that particular environment? Is it like pinning one thread per core to like try to, or is it less threads than the total number of cores, or would you get or would you get more efficiency if you sort of doubled up threads on a core?
Sure. So it is a combination of number of threads per core and also number of applications. So for example, if you have, say, our latest CPU has 48 cores, and if you run it in a multi-threaded form, you'll get 96 threads. Now, if you have that many number of applications, like one core, one thread, each application gets one thread, then you don't have context switching happening. As you want to host many more, because your threads are not always utilized. So service providers and application developers want to run many more. So they may want to run, like I was saying, 1,000 microservices on a 100 thread system. Then your context switches are going to be higher. So it is how the deployment is. Now, if there is a system which has many more threads, I don't see one right now. One core, two thread, dual thread systems are there right now. And so you can oversubscribe. That's why we had virtualization, was for switching and making use of many number of threads, right? So your utilization of your system is much higher. So if your utilization, you want to increase the utilization, and you want to increase the number of microservices, you're also increasing the number of sidecar elements. So that's another bottleneck to look at. The number of, what is the infrastructure overhead for hosting that many number of microservices is something to look at. And hopefully the service mesh deployment and the performance data that we give through SMP can help decide that for the customer.
I knew it was like there was general guidance, but then it's like a big fat, it depends type answer. Well, as we've been talking here, I've just kind of browsed over these 4 different areas, aspects of the project, between well, between enhancing the specification to get even more specific, like Ritika was saying about how far, well, the level of depth and specificity that's you can capture in the spec. Getting all of you and more folks involved to participate. That's the participation that we're also looking to do is increase with some of the service meshes themselves. Each of them are aware of the initiative, and some of them are much more excited to be measured than others. And so we want to make it very welcoming for all of them to come and self-measure and self-report. Another aspect of the project is about research. So we're talking about, we were alluding to a potential mesh mark. I don't know, we haven't talked about some advanced things that we want to do with one of the load generators, Nighthawk, but that's on the agenda, like that's part of the within scope. Another one is trying to share as much of these learnings as possible and publishing these things. And doing so with what I was saying to Jin earlier is doing so in a continuous manner. Like, and it'll take some feedback from all of you to understand whether or not we're really have the right configuration or interesting configurations. If the applications that we're using are representative of your workloads or not. If the type of test, whether it's a longevity test, like a soak test or some spike test, or like the intensity by which load is being applied, if that's interesting to all of you, these are the types of questions that I know Jin and others have, and they're going to they're going to just take their best guess at it until you all come by and give some more input as to what your environments look like. To do so, and like to jump into any of these areas, one of the probably the best thing to do is to go to smp-spec.io, to just go to the project site itself and engage, either jump onto the mailing list or jump into the CNCF Slack and provide that feedback, like make some requests. It's just, we're soliciting your input here. So and so Jin, I put a bunch of words in your mouth. And so just to be sensitive to doing that, anything that you wanted to add to take some words out of your mouth?
Yes, actually, I have a question about, maybe everyone has their own mesh product or have on their workloads, their own application. So do we want to provide a way for users to run their own mesh or applications in SMP or Meshery?
What a beautiful question. Nivendu, do you want to take this one?
Surely. So Meshery, being the service mesh management plane, facilitates users bringing in their own applications. So Meshery has a construct called Meshery applications, where users can import their own applications and use Meshery to deploy those applications on top of the service meshes. And yeah, like so Meshery does on top of the sample applications that I shared in the chat. Meshery can also manage custom applications that users can bring in. So if the sample application doesn't represent the exact workload they have on production, then they can bring in their custom workloads to run performance benchmarks. And yeah, so the short answer to your question is yes, we are doing that right now, and that would also help the users, I guess.
Thank you.
And so, like, yeah, what a fantastic question, because yeah, which kind of speaks to the need for not only continually publishing those benchmarks, but then also, at least from my perspective, the significant enablement of like handing everyone the tools to do it themselves. Publishing some reports, publishing what experts like Jin and Martika think about what types of tests are interesting, some of the insights that they've already gleaned and can share, kind of point people in the right direction in terms of like, here's other environments and what we've seen in those environments. But then, yeah, enabling everyone with the same tooling and hence like using the same specification to be able to go into their environment and then like assess whether or not they're doing well relative to, others who are relative to the other benchmarks. It's a really, yeah. I'm curious, by the way, so
I had a question for you, Lee.
Mhm.
I don't know if everybody in the stock knows about more about SMP, what it is, how it became a CNCF project, what the goals are. I think some folks, this will be good to go over once more what has been started off, how people can take part in this, whether they contribute by code or by, like Rin mentioned, people may have their own service mesh, which can be a little different, may not be how that can be brought in. I mean, something you can talk about that?
Yeah, thanks for asking. Actually, I'm gonna point this out. I don't know if this is a point of pride or not, but there's so like the brief answer to the question is like, absolutely jump in. You don't have to write any code. Please come and express opinion every which way, ask a ton of questions, make suggestions about what types of applications and what types of test configurations, all of that. And I think that it's actually a really important question that about whether or not you need to write code to do this stuff. And it's like, actually, no, please don't. It's kind of, it's part of the ask. So if you were to go to contribute.cncf.io, this is just as an example to show how important what Ritika's question is. When you go find the Service Mesh Performance Project, like, and you see a list of what the project is about and what skills someone might need to, engage in the project and contribute. It's the only one that says DevOps next to it. And what DevOps means, I don't know, but it's intended to mean sysadmin skills or like operational skills of like exactly what Ritika was saying is in order for the project to go prominently publish benchmarks and enable people with this knowledge. It's not about code as much as it's about like bringing representative examples of like the type of layer 7 traffic, to what Martika was saying before, that's of interest, the intensity of that, the type of environments that you're in, like just providing that feedback. Then also engaging in like running the test locally, potentially sharing the results back. Those can be shared back anonymously. So ultimately, like the more diversity of environments that are measured, the more data there is to analyze and insights there is to glean. I think that's kind of part of the answer. The other part of the answer is yes, he's getting back, like to again, to just kind of do a quick repeat, like the genesis of the project is, it is about enabling people with information. Like how much, before I even come to a service mesh, what can I expect that I might have to pay to run one of these things? Like, yes, I see the value. I'll get uniform telemetry. I'll get tight granular control over my layer 7 traffic. I'll get built-in security in between, like you'll get any of these things. And then, like, what's that going to cost me? Also, how much overhead can I eliminate from a different metric system or different logging system? Or if I was running a separate certificate management system, and now the mesh provides me one, and it does, it generates these certificates and rotates them for me. Like, if I can disable these other systems, how much, these are all considerations. Like, how much do I save by disabling them? How much can I expect to kind of pay, so to speak, in terms of overhead here? How do I know if I'm doing it well, if I'm paying way too much? And like, part of those sets of considerations and this information is shared through the project, also hopefully helps enlighten you as to the cost of one type of, just as an example, like, what's the specific cost of, like, this isn't specific, like, what's the high level cost of logs and having a service mesh generate those at maybe a high rate versus distributed traces and generating those maybe at a high rate? Like, that's a fairly macro level thing to look at, but if there's an order of magnitude difference, and maybe one of those telemetric signals is more important to you than the next, then at least, then you have a starting point and you can go from there. How much, like, between, like, the other simple, like, and very specific insights that hopefully S&P will provide people is things like, what can I generally expect would be overhead for mutual TLS, or like for enabling and requiring encryption between my environments? And then having a base understanding of that, even if it isn't your environment, would be like to go back and reflect on how critical that is in your environments. And so, yeah, that's those are kind of all within scope of why the project got started. Like, because you just, in part because it really needed a vendor neutral place for these discussions to happen. It's all too easy for any of us to want to, any service mesh project in specific, to show bias toward their project. It's a natural thing to do. And most of the freely available blog posts out there are incidentally tainted by who generated them. And it's been a conscientious consideration as part of this project that those that are involved aren't manipulating the figures, aren't trying to skew the results. Like, so.
That's a good answer.
I recognize that we're, I think, close to time. Did we miss anything? Did anybody have any other questions that we didn't get to by chance? And so, Ritika, actually, since you've got an upcoming talk that's also friendly to the China time zone, so remind us again, like, where.
So this is IEEE Edge, and folks have to register to attend the IEEE Edge conference. I can post the link to it. It's happening 18th, 19th, and 20th. And give me a minute and I will post more details around that. So you can attend it, or the paper will be out when IEEE publishes it. IEEE Edge 2021. And this is largely happening in Guangzhou, China. And the paper we have is around talking about one of our benchmarking environments where we ran on a certain type of hardware, and what kind of results we got from each layer of hardware, and what exactly what one of the panelists or one of the attendees today talked about, how service mesh adds adds latencies And so we did more analysis around that.
Very good.
And I'm hoping some of the learnings we had, we are going to be able to, add some of that to SMP and build something around it so other people can, measure within their environment. Instead of us, we did it in a staged manner, whereas SMP will bring it together in one tool.
We're at a minute out, and so this has been great. Like, I love talking about service mesh. It's been very nice. Very nice to have the other maintainers on. Thank you for sharing today. Actually, I guess that's it. So we're at time, and it's been nice to chat with you all. We'll be probably available in Slack for a bit. So hit us up if you have more questions. Otherwise, have a great KubeCon. We'll see you all.
Thank you, everyone.
Thank you, everyone. Bye.
Thank you.
Bye. Bye.